Hello, folks of geometry. We're coming towards the end of Unit 2. This will be the last section of the unit. So we're talking about proving lines parallel. Basically, and proof is such a big part of mathematics, especially as you get more in depth and as you get to higher level. Proof is going to come into play more and more. And it will come into play quite a bit in Unit 3, and I'll explain to you how. But for now, what we're trying to do is prove lines are parallel. So what we've done previously is we've said, okay, we have these parallel lines, okay, they're cut by a transversal, but you were told they were parallel, and then all of this stuff happens. Okay, there's these different types of angles, different pairs of angles, and all these different things happen. So now we're going to kind of back up. So now we're going to say, I know that this situation is true. And if I know that situation is true, that can tell me that the lines are parallel. So here, the converse of the corresponding angles postulate says this. So previously we said, angle A, or line A is parallel to B. So 1 is congruent to 3. 1 is congruent to 3. Those are corresponding. 2 would be congruent to 4. 8 would be congruent to 6. And 7 would be congruent to 5. We would say, because these lines are parallel, all of this happens. Okay? So this was the big concept. I would have to say, hey, these two things are parallel. Because it's parallel, all of this is true. So now I'm saying it backwards. Now, I don't know that the lines are parallel. So what I'm saying is, if two corresponding angles are congruent, then the lines are parallel. So if you notice an if-then statement, yes, that kind of goes back to the logic. And this is actually what you would call a converse of what we spoke about at the end of Unit 1 with the angle relationships piece. Or I'm sorry, it was rather 2.1. So it's just kind of flipping it around. Previously I'd said, hey, the lines are parallel, then any two corresponding angles are congruent. So now I'm flipping it around and saying, if I can show, or if it is shown to me that two corresponding angles are congruent, then I can argue that the lines are parallel. Okay, so it's just kind of flipping around what we have said previously. Okay, and that's just for corresponding angles. So remember, corresponding angles, these were the ones that were in the same location, okay, with respect to their line. Okay, so given the following information, is it possible to prove that any lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So I'm given that 1 is congruent to 3. So 1 is here, 3 is here. Okay, so 1 and 3, those are in the same location. Those are both kind of below their line and to the right of this line, which I could consider a transversal. So I can argue, this statement is true, 1 is congruent to 3. Then I can say, then A is parallel to B, okay, by the corresponding angles theorem. And you could say converse of corresponding angles theorem. That's kind of what the idea is. So I can say converse of corresponding angles theorem, but I would accept corresponding angles theorem if you wanted to shorten that up. So now here's an idea that takes a little bit of thinking, but the more you think about it, the more it makes sense. You have a given line, okay, just an arbitrary line, and a point not on the line. There's one line and one line only through this point that is parallel to this line. there is one line that goes through here, one distinct line that is parallel to this. And I know some of you are thinking, good grief, Mr. Heeren, that's painfully obvious. There can only be one line. Well, this is one of those things in mathematics that we often have to say, and that is that we often just kind of generally accept them, like parallel postulate. Well, you know, if this was also parallel to this, you know, you would have to prove that these two are the same line. Or that, you know, just there's no other distinct line that could also be parallel. So this is just a concept to think about, that one and only one line goes through P that is parallel to M. There's also a perpendicular postulate which says, you know, through P, there's only one line that is perpendicular to M. But we're not talking about that right now. So for any given line and any given point out of the line, there's exactly one line parallel through that point to the other line. Okay. So now it's taken one step further, alternate exterior angles, and it's similar to the corresponding one where I can say if two alternate exterior angles are congruent, then the lines are parallel. And likewise, you know, if two consecutive interior, but consecutive interior is different. Two consecutive interior angles are supplementary. This was the one situation. Okay, this was the one situation where they are not congruent. Then the lines are parallel. Okay, so if I can say A and B, so if A is congruent to B, then line X is parallel to Y. And these are all the same relationships that we spoke about before. I mean, nothing is really brain-breaking here. It's just kind of saying it in reverse order. So here, if I've got C and D, we'll stick with our X and Y. So if I can say, you know, if angle C plus angle D equals 180, then X is parallel to Y. And that's really all I'm saying, is that if I can show that this is the case, then I can say, yeah, the lines are parallel. That's all I'm saying. So the alternate interior angles is the same idea, except just the pair that we haven't talked about yet. So if two alternate interior angles are congruent, then the lines are parallel. So if I consider E and F, we'll stick with the X and Y. So if E is congruent to F, then X is parallel to Y. So if the angles are congruent, then I can say then the lines are parallel. The perpendicular transversal converse There's a lot of big words, and it's a fancy way of saying, I'll sketch the picture first before I put it into words. So perpendicular transversal. So remember, okay, so remember I have two parallel lines of transversal cuts through them. And we're saying that, it's perpendicular here and it's perpendicular here. So what this says is, if it's perpendicular in both, then those lines are parallel. Okay, so if I can say if a line, remember we don't know it's the transversal yet, if a line is perpendicular to two distinct lines, and I use the word distinct because I don't want this to be like, I don't want one line to be named multiple times and then say, oh, they're parallel. Well, no, they're exactly the same. So if a line is perpendicular to two distinct lines, then those lines are parallel. Okay, so if I said, we'll call this T, A, and B. So if T is perpendicular to A and T is perpendicular to B, then A is parallel to B. And this is a very clever one. I mean, it seems like it's pretty obvious, but this was really clever. So if it's perpendicular to both, then those two are going to be parallel. So now as we look, let's kind of look and see what we have here. So I have angle 1 and angle 6. Well, angle 1 is up here. Angle 6 is up here, or down here. So for the current moment, I just kind of ignore this middle stuff. And I look at where they're located. 1 and 6 appear to both be exterior, and they are alternate. Okay, so they are alternate exterior. And in that situation, if they're congruent, then I can say the lines are congruent. So here I can say, yes, L is going to be parallel to N by alternate exterior angles. Okay, that's the first one. The second one, 2 and 3, so 2 is here, 3 is here. So I don't need this stuff down here, so I kind of ignore it. 2 and 3 would be alternate interior. Okay, so I would say that, yes, L, in this case, is parallel to M by alternate interior angles. THM is just shorthand for theorem. So alternate interior angles theorem, or the converse if you want to be very picky about it, which I encourage you to be. So those are going to be my justifications, my reasoning as to why those lines are going to be parallel. So that's kind of what I'm looking at doing. Okay, so now we have two lines cut by two other lines. So let's kind of look at what we have. So number 4 says 2 and 8. So 2 is here, 8 is here. So I kind of ignore all this other stuff. Okay, L becomes a transversal. A and B are the lines I'm looking at. So I would say I can argue that A is parallel to B, okay, by alternate interior angle theorem. Okay, because if I turn and look, these are my lines. L would be my transversal. So 2 and 8 from that perspective would be on the interior and on opposite sides of my transversal. So that's what I would consider. So the next one, 3 and 11. Okay, I'm going to ignore all this. 3 and 11 appear to be in the same location. So I would argue, yes, L is parallel to M because they're in the same location, corresponding angles theorem. Okay, corresponding angles, they're in the same location. That's all I need to tell me, yes, those are congruent. Let's see. 1 and 15. 1 and 15 have no relationship. Okay, now I know what you're saying, but Mr. Heeren, they're both exterior, and that's true. But in order for that to work, I would have to show, you would need more information. You would need to show like 1 and 11 are congruent because those would be alternate exterior angles. Or you would need to say like 1 and 7 and then 7 and 15 because they're corresponding. 1 and 15 by itself doesn't tell me enough information. So I would say NEI, not enough information there. So we have a ladder. Each rung is 2 rails. Is it possible to prove that the 2 rails are parallel and that all the rungs are parallel? If so, explain how. If not, explain why. So here's what we have. Okay, we have this ladder. And I would argue that so the 2 rails are the sides, and then you have the 2 rungs. Is it possible to prove that the 2 rails are parallel? And so we have the 2 rails, and then parallel. And I would say yes. And why? And I would say it's because each rung is perpendicular to both rails. Okay, so each rung, each thing here, each step in the ladder, if you're going to argue it that way, each rung is perpendicular to both rails. So if it's perpendicular to both rails, then the rails are parallel. And then for the rungs, switch gears here, for the rungs, are they parallel? Yes, if it's a good ladder. Why? Each rung, each pair of rungs is perpendicular to the rails. Okay, therefore, they are parallel. And I apologize for if my handwriting is tough. It's just I'm trying to get through that in a bit of a hurry. So each pair of rungs is perpendicular to the rail, perpendicular to the rail. I mean, that's enough to say that they're going to be equal to each other, or not equal, but parallel. So let's take a look here. In rowing, or crew as they call it, rowers' oars should be parallel. Refer to the order. Refer to the photo. Is it possible to prove that any of the oars are parallel? If so, explain how. If not, explain why not. So if I look, so we have this, the boat is my straight line here. Okay, so we have an angle of 110 and an angle of 80. 110 plus 80 is 190. So they're 110 obviously does not equal 80. So I'm going to say not possible to prove. Okay, because there is no relationship, I should say no angle relationship, that gives us enough information to say that those lines are parallel. Okay, there's no angle relationship that allows us to say if lines are parallel. Okay, there's not. I mean, you don't know how big this angle is. You don't. Well, I mean, you could argue that this is going to be 70. This is going to be 100. So that's 70. That's 100. That doesn't help us at all. So I'm saying it's not possible to prove that any of the words are parallel. We just don't know enough angle information to tell us. Okay, so those are the four things that you're going to want to look for. Okay, so the corresponding alternate interior, alternate exterior, the consecutive, and then the little perpendicular piece that went with it. So now, what do you have left? So obviously you do 2.4 in quizzes. And then you're working on your Unit 2 review. And then you're going to work on your Unit 2 test. Okay, so that's what's next. All right, thank you very much.